the Trick Fairies!
I'm a Puff!
And I'm a Poof.
Can you guys help me?
Our job is to help you succeed.
You'll become a more wonderful person.
Some wonderfully helpful background information about vectors.
A vector is a quantity with both magnitude and direction.
The length or given value of the line segment that represents the vector is called the magnitude.
The direction of the vector is the angle between the positive x-axis and the vector.
The sum of two or more vectors is called the resultant.
Okay, this is great. But how do I find the horizontal component?
No worries, we'll be absolutely happy to show you how to find it.
Wait, but how is this a vector?
The force exerted on me, le Poof, is a vector because it has both magnitude, which is the strength of the force, and direction, which is 30 degrees above the horizontal.
It says to find the horizontal component? How do you do that?
We can use trig ratios to find the horizontal component.
What are trig ratios?
You know, sine, cosine, and all that jazz.
We will use cosine for this wonderful problem. The hypotenuse of the triangle is a part of the diagram representing the force on the rope. We want to find the horizontal part of the triangle.
Also, the angle of elevation is 30 degrees and I'm pulling with the force of 4,000 newtons.
So how do we find the horizontal component?
We use the cosine ratio. The cosine of 30 degrees is the horizontal component over that hypotenuse.
We can rearrange the equation to find the horizontal component. It is cosine 30 degrees times the hypotenuse, or 2,000 square root of 3.
Wow, you guys are so helpful. But how do I do the next problem?
No need to fear, the Trick Fairies are here! Stay full of cheer.
This one is so much harder. I need to find the work done by gravity as a person pushes something up a driveway. Ugh, so hard.
We shall show you the way.
Work is defined as the force times the distance, which is at the same direction as the force. Since the force of gravity acts downward, the force is vertical, so we want the vertical distance.
We can take the magnitude of the force of gravity and multiply it by the vertical distance between the starting point and ending point. Since we only need the force of gravity, we can ignore the force of the push.
The force of gravity in newtons is equal to the weight of the crate in APA in kilograms, which is 6 times 9.8, a number that represents the acceleration due to gravity. This is 58.8 newtons.
But why 9.8?
Well, it is an accepted value representing acceleration due to gravity, and the force of gravity is always found in this way, so that's how you should do it.
We can also measure the vertical distance between the starting point and ending point, which is 1.2 meters.
Now we just multiply the force times this distance, and now you have the work done by gravity, which is 70.5.
Wow, you guys are so amazing and helpful and beautiful.
Anytime, my friend.
But wait, I have one more problem to go.
We can handle it. We're all in this together.
We're all in this together.
Okay, here's my problem. Nathan wants to hang a calendar supported equally by two cables. The cables form an 120-degree angle with each other. The calendar weighs 1 kilogram, and we have to find the force exerted on each of the cables.
Let's draw the diagram first. Yeah! We will use a tip-to-tail diagram.
Because the triangle is isosceles, the base angles are congruent, which makes them equal to 65 degrees.
After we use the law of sines to find the force exerted by the cables, we get about 3.667 kilograms.
I'm done! Thanks, guys. You're so helpful and beautiful and amazing.